All right, so this is a standard that we did last quarter, but we're going to go ahead and revisit again right now. So it's EMI 501, and this is going to be in your Daily Dose of Fun module for Q2 Week 2. So, flipping to the first question, we're going to go over 1 through 5 in the first video. It says, based on tables 1 and 2. So, my steps here, read the question, and then you highlight where to go. Highlight where. And then pick the key terms, and then you match. So we only saw this in Fighting Scientist passages, but you can actually see this in tables and graphs too. So for here, based on tables 1 and 2, so I know I'm going to look both. If the difference in electronegativity between two elements is high, the two elements cannot share electrons, cannot bond, tend to form molecules with low percent ionic character, and tend to form molecules with high percent ionic character. I'm crossing off A and B because if two choices are near identical, one is the answer. So if two of your choices are near identical, like C and D are, one of them is the answer. So I'm looking for low percent ionic character and high percent ionic character. So table 1 shows me the percent ionic character. And now this says if the difference in electronegativity between two elements is high. So this is C and O, H and Cl, MgS, AgO, HF, MgO, NaCl, and NaF. So then we need to figure out the percent ionic character for these. So let's say it's low from 43 and below, and it's high over 50. So this is 50 to 100, and this is 0 to 49. All right, now I'm going to look at table 2 and figure this out. So our first one that we need to look at is C and O. Well, actually, we only need to look at the high difference in electron. Okay, so we're going to do this. So C and O. That's 2.55 and 3.54, so that's about 1 point something. All right, then H and Cl. H to Cl is 2.2 and 3.16, so that's again 1 point something. Mg and S, 1.31 to 2.58, 1 point something. AgO. Ag and O is 1.93, 3.44. Okay, now let's look at these ones. H and F. H is 2.2, F is 3.98, that's almost 2. Mg and O is 1.31 and 3.44, that's around 2. So it looks like these numbers are bigger than these numbers if you flip back. So the percent ionic character is going to have, so if the difference in electronegativity between the two elements is high, the elements, so this is high, and this is our higher ionic character. So the answer for this one is D. All right, number 2. Based on the information in the passage, elements that have similar electronegativity values will not form molecules that are. Now it says in the passage, so we're looking at the whole thing here, but first, 100% ionic character is an ionic bond. 0% ionic character is a covalent bond. Most chemical bonds lie between these two extremes. So we need elements that have similar electronegativity. So let's look at ones that have similar electronegativity right here. So let's see, C and S have similar electronegativity. O and F have similar electronegativity. So C and S, 3.16, 1.93, 0.93, 2.2. Those are really the most similar ones that we can look at. So, our purely covalent, our purely ionic, have percent ionic characters less than 50, share electrons unevenly. So let's look at here. Elements that have similar electronegativity will not form molecules that are. So if I look at these ones right here, this is a nonmetal, 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 nonmetal. And that means, and it says will not, so that's a key term here. Everything we circled is a non-metal, which you will learn about in this quarter a little bit later. And then let's look at these. We have F and O. So we have C and O. We have F and H. F and S. I'm not seeing those. So if we look at the ones that are here, C, O, and H and F, both of those have a low ionic character here. So it cannot be purely ionic. So nothing here that we have to look at here. So we saw one of 18, so it can't be that. Share electrons unevenly, are purely covalent, are purely ionic. Now, here's the key here. Based on the information in the passage, it says 100% ionic character indicates a purely ionic bond. 0% ionic character indicates a purely covalent bond. We did not have H2. That's purely covalent. So H2 together. And that's going to be the most extreme. And we have nothing on the table. So 100 is not listed. So that means it cannot be purely ionic. All right, number 3. According to tables 1 and 2, a percent ionic character of 0 is most likely due to the absence of bonds in a molecule. The one that has an ionic bond of 0 is H2. That means H is bonded to H. The bonding of elements equal in electronegativity, the presence of H in a molecule, the formation of an ionic bond between two elements. So it cannot be this one because we want 0 ionic character. So that's just gone there. And it can't be A because we know they're bonded. So that means for 3, we're looking for the answer. The bonding of elements equal in electronegativity. So we have H bonded with H, which means it's 2.2 bonded with 2.2. So the answer there is B. And we know that it's not C, right? Because other compounds that have H's in them, like right here and right here, have ionic character. All right, number 4. Which of the following conclusions can be correctly drawn based on the information presented in Table 1 and 2? So I'm looking at both. Percent ionic character is related to the difference in electronegativity between atoms in a molecule. We can go ahead and keep that in there because that's what we've been talking about in every single question. An element with an electronegativity of less than 1 will not form bonds with another element. So if I look here, less than 1, Na is here. Is Na on our list here? Yes, twice. So it can't be B. Percent ionic character can be negative if the elements in a molecule have very different electronegativity. That's a no because the passage tells us it's 0 to 100. I'm not going to make that joke. If you're making it while you're watching it, that's fine. Percent ionic character can be negative if the elements in a molecule have the same electronegativity. Again, it can't be this one because it's 0 to 100. So your answer to this one is A. Now here is the one place where my strategy didn't make sense, that if two choices are identical, one of them is the answer. But that's because this directly contradicts the passage. So this question is trying to trick you.